Tiga.
Assalamualaikum warahmatullahi wabarakatuh. We're gonna present about the wine quality for subject STA 600. I'm Ami Imran bin Ramli as the presenter number one.
I'm Muhammad Afif Akmal bin Mat Lahan as a presenter number 2.
Mine was Wan Muhammad Kawimi Wan Sulaiman as presenter number 3.
My name is Iman Aziz bin Ahmad Nizam and I am acting as the last presenter.
So for background of the study, the wine quality is often based on cultural percept, training, and experience. Ideally, this reflect the sensory characteristic of the wine. Not surprisingly, quality often is defined in that diverse way. It may evaluate in terms of subtlety and complexity, aging potential, stylistic purity, varietal expression, prestige, expert ranking, or consumer acceptance. Each has its justification and limitation. Next. Next. So the problem statement is wine is the one of the best non-alcoholic drink. Lately, wine has become a trend and their quality is very taken seriously by the buyer, which is the drinker. However, the factor that affect the wine quality has not been studied. Hence, this study is made to explore the factor that affect the quality of wine. Next. So this is the theoretical framework which is the fixed acidity, volatile acidity, citric acid, residual sugar, chloride, free sulfur dioxide, total sulfur dioxide, density, pH, sulfates and alcohol is the X, and wine quality is the Y.
For research objective for this project is to experiment the different classification method to see which yield the highest accuracy. The second research objective is to determine the features are the most indicative of a good quality wine. Next, we move to research hypothesis. So in this study, there are 11 hypotheses that we want to achieve. The first is fixed acidity affecting the wine quality. The second is volatile acidity affect the wine quality. The number 3 is citric acid affect the wine quality. Number 4 is residual sugar affect the wine quality. Number 5, chloride affect the wine quality. Number 6, free sulfur dioxide affect the wine quality. Number 7, the total sulfur dioxide affect the wine quality. Number 8, the density affect the wine quality. Number 9, pH affect the wine quality. Number 10, sulfate affect the wine quality. And the last 11, alcohol affect the wine quality. Okay. Significant and limitation in this study is this study is significant to the wine lover and dealer. It will help the drinkers to know the factor that affect the wine quality. Then the limitation is time constraint and journal availability. For the methodology in this study, we use multiple linear regression. Multiple linear regression is a mathematical method that uses a verify of explanatory variable to predict the outcome of the responder variable. So the multiple linear regression based on the following assumption. There is a linear relationship between independent and dependent variable. The independent variable are not too highly correlated that with each others. Okay, and the observation are selected independently and randomly from the population. Then residual normally distributed with mean 0.
Okay, now we will discuss about the analysis and the result in part A. So, based on the pie chart, there is 83% of the sample is known as white wine, meanwhile the rest is red wine. So, I've used Microsoft Excel to do a randomize to select a sample about 150 out of 6,443. Next. Okay, based on this bar graph, it shows that white wine is more quality, better than red wine. Next. So after I've run the analysis, this is the output from the coefficient table. We can see that there are about 10 independent variable which is not significant because the value is larger than the alpha 0.05. The independent variable that are not significant is type of wine, fixed acidity, citric acid, residual sugar, chlorides, total sulfur dioxide, density, pH, sulfates and alcohol. Next. So this is the ANOVA table. F-test will be used to determine whether there is a relation between the response variable and the set of independent variable. So based on the significant value, it shows that this model is significant by comparing with alpha value. Next. So I want to test the independent and dependent linear relationship. So this is one of the independent that I select, which is dependent variable quality and independent is alcohol. So from this graph, it shows that this comparison that no linear relationship. Next. This is quality and pH also don't have a linear relationship. Next. And the last randomly selected variable is residual sugar and quality. Also this one have no linear relationship, so the assumption of the relation function is not fulfilled because the relationship between the dependent and independent variable is nonlinear. Then the transformation is supposed to be done. Next. So I want to check the error terms. Is that error term are normally distributed or not? So all the data is lies about 45 degree. So we can assume that the error terms are normally distributed. Next. So this is scatter plot, standardized residual versus standardized predicted value. This scatter plot is want to examine whether the error variance is constant or not. By looking at the plot, we can say that the error variance is not constant. So the homoscedasticity is exists. Next. Okay. This is a model summary. We can look at the R square value, which is too low, 0.315, which is about 31.50% of the total variation in quality of wine can be explained by the level of alcoholic, sulfate, citric acid, free sulfur dioxide, pH, chloride, residual sugar, fixed acidity, volatile acidity, total sulfur dioxide, density, and the type of wine. Well, the rest, the balance is about 68.50% can be explained by the other factors. So, from this R value, you can show that the independent variable does not affect the quality of wine. Next. Next we want to check the multi-collinearity exists between the independent variable. So basically multi-collinearity, we can say that is there any significant between independent variable? So we can look at tolerance and VIF values to detect is there have multi-collinearity exists. So if the independent variable at tolerance value is uh, more than 10, which means there is have a multi-collinearity exists. The good is mass is less than 10. Meanwhile, the VIF value is mass upper than 0.2. So about three independent variable we can find at tolerance value has multi-collinearity, and about four variable at VIF value we can detect multi-collinearity exists. Next. So lastly, in this analysis part A, we want to detect the outlier. So first, I want to detect the outlier at Y observation by checking the student dilated residual and student dust residual value. This value must not be exceed at either positive 3 or negative 3. So from the observation, I can say that there is no observation that outlying the observation Y, because there's no such a value that greater than 3 or less than negative 3. Next. Second, and next I want to check the outlier at X observation by using uh, by using leverage value. Sorry, leverage value. So from the leverage value, I calculate is 0.16. So any leverage value that greater or less than is not include is determined by sorry, not determined, is known as considered as outlying X observation. So there is about the observation number 1, 18, 33, 90, 111, 132, 139, 142, and 150. So the next step I make is to check is there any influential cases at this observation of X. So I examine by leverage examine the influential cases by using Cook's D value and the F fit value. So from the F fit value, I calculate is about 0.5657, and for Cook's D value is 0.02899. So any observation that more than the value I have stated is considered as a influential cases. So I have decided that the value observation from number 1, 18, and 139 as a influential points, because this point is fulfill the assumption to remove. So therefore this observation should be removed from the model. As a conclusion from part A, we need to perform a transformation to achieve the linear relationship between independent and dependent variable. So I pass to Iman and Haziq.
As our friend said, while Muhammad Kawi said we need to do a transformation. So there are a few transformation that we can do to fulfill the assumption for regression function. So there's three transformation that we are using. The y is equal to square root of y. There's a typo right here. It's actually square root, and then the second one is ln y, and then the third one is 1 over y. Okay. So uh, after we have done the transformation, we can see that the square root y has the highest r squared value, which is 0.276, which are the highest among the three. So we can only use the model that are using transformation square root y. So for the f test of relation in the final model, we can see that the study has found that the p-value for the model is 0.0, which is less than alpha value 0.05. So the study concluded that the model is valid for this data. So proceed to the next results. But we want to check the fitness of the model. By using the r squared and adjusted r squared. We will be using the adjusted r squared since it is more accurate. So since the value is 0.256, we can conclude that 25.6% of the total variation of the wine quality is explained by alcohol, volatile acidity, free sulfur dioxide, and chlorides, which is the significant variables. So proceed to the next results, where we want to test the significance of each independent variable in the final model. So we can see that there's a four model that we have created because we are using a stepwise method to remove the not significant variable and end up with four significant variable only, which is alcohol, volatile acidity, free sulfur dioxide, and the last significant variable is chloride, since the p-value is all of the p-value is less than 0.05. And then we proceed to the next result, where we want to find the linearity between independent variable and dependent variable. Okay, based on the ANOVA output table, the study that has the significant value for deviation from linearity is 0.970, which is more than 0.05. So it can be concluded that there is a linear relationship between the independent variable and the dependent variable. Okay, proceed to the next result, where we want to check the normality. Okay, the study has found out from the PP plot that show right here, that most of the point lies near the fitted fitted line. So we can conclude that the data is normal. And then we proceed to the next finding, where we want to see the consistency of the error variance. We can see that the scatter plot shows that the plot are not randomly scattered. There are a few lines formed in the graph, so we can conclude that the error variance is consistent. And then we proceed to the independence of the error term. We want to check the value of the B Watson. So we have found that the value of the B Watson is 2.004, which is in the range of 1.8 and 2.2. So there is no autocorrelation. For the multicollinearity, we can check the VIF value, which is more than there is no variable that has VIF value that is more than 10 and tolerance value which is less than 0.2, because the model is the model that we are showing is the significant model. So the not significant model has been removed from this result. So the four model that is significant alcohol, volatile acidity, free sulfur dioxide, and chlorides. Okay, next. Okay, for the conclusion, uh, we can see that there is a positive relationship between wine content and wine quality. Even though the model that we get are not the best for the model are not the best for the data, since the R squared value is less than 0.6. But between the three transformation that we have been using, this is the best that we can do. We can apply to our data. So the independent variable, which are wine content, are divided into 12 categories, which I have been informed, and then we have found that there are only 4 significant categories, which is alcohol, volatile acidity, free sulfur dioxide, and chlorides that affecting the wine quality. So that's all from us. Thank you.
Thank you.